It seems there's no other place in the universe with a dense atmosphere. Mountains, sand dunes, plains, lakes, rivers and oceans, except the planet Earth. But it turns out there's actually a place much like the Earth in our solar system that has a complex weather cycle, landscapes carved by liquid, and volcanic activity. It may even resemble the Earth in its earliest stages, and some scientists think it might be better to colonize it first instead of Mars. This is Saturn's moon, Titan. Recently, something bizarre was found hidden in its orange clouds, and because of this, NASA is now planning a mission to Titan. But what did they find, and why was it so important? Before we get to that, let's learn a little about this strange world that orbits Saturn. Our solar system is home to more than 150 moons, but only 4 of those have an atmosphere. One of those is Titan, the second largest moon in our solar system and the largest moon of the planet Saturn. Titan is also the only place in the solar system other than the planet Earth that has liquids on its surface. It has a weather cycle much like ours, but has clouds that rain frozen liquid methane and ethane instead of water. Titan could be the best place for human colonization. In fact, the conditions are right for a self-sustaining, long-term human settlement. Titan is a remarkably Earth-like world that has a thick atmosphere, about 4 times as thick as Earth's. The atmospheric pressure is about 60% greater than on Earth. Imagine swimming 50 feet underwater to give you an idea. This means you wouldn't have to wear a bulky pressurization suit if you were walking around on the surface. The atmosphere would also keep out deadly radiation, energetic particles from the sun, and galactic cosmic rays from making it to the surface of Titan, making it a safe environment for humans. Mars doesn't have such protection. People living on Titan could walk or bounce around since gravity is only 14% of the Earth's. If you strapped some wings on yourself, you could literally fly around under your own power. But it's very cold on Titan, because on average it's 886 million miles from the sun. You would need a suit to keep warm, because the surface temperature is about minus 290 degrees Fahrenheit, and the only sunlight that reaches its surface is like late sunsets on Earth. Of course, you'd also need to wear a respirator to breathe. Titan is tidally locked to Saturn, meaning one side always faces the planet. It's 759,000 miles away from Saturn and has a radius of about 1,600 miles. It takes the Titan 15 days and 22 hours to make a full orbit of Saturn and 29 Earth years to make a complete orbit around the Sun. No one is certain what Titan looks like under the surface, but on January 14, 2005, the European Space Agency's robotic lander Hyans made a dramatic descent through the moon's orange smoggy atmosphere and landed on the surface of the moon. The camera on Hyans shows a desolate-looking surface and captured the trademark yellow haze, which revealed intricate details of the atmosphere's layers, winds, and mysterious chemical processes. Based on data from the Cassini-Hyans mission, Titan has 5 primary layers of rock. The soggy moon has a core of water-bearing silicate rock surrounded by a shell of special water ice called Ice 6 that's found only at extremely high pressures. This high-pressure ice is surrounded by a layer of salty liquid, and an outer crust of water ice sits on top of this. The surface is coated with organic molecules that have rained or settled out of the atmosphere in forms of sands and liquids. The presence of lakes and seas on Titan brings up an interesting question. Could there possibly be any forms of life there? In 2005, scientists at the Southwestern Research Institute in Texas and Washington State University said that several of the crucial elements for life on Earth are also on Titan, even though the conditions are far harsher than Earth. Some life forms are a lot tougher and stranger than we think. Take, for instance, Deinococcus radiodurans bacteria, an extremophile that was in outer space for 3 years outside of the International Space Station, enduring microgravity, harsh ultraviolet radiation, temperatures near absolute zero, and still managed to survive. If there's life on Titan, it could be hidden underground, and a lot weirder than we think. The Cassini spacecraft revealed that the moon is hiding an underground ocean of liquid water mixed with salts and ammonia. Titan could potentially have environments with conditions suitable for life as we know it in the subsurface ocean, or bizarre alien life that we don't know about yet in the hydrocarbon liquid on the surface. But what happened there recently that drew our attention there? In 2016, a team of scientists identified a molecule called cyclopropenaldine, C3H2, in Titan's atmosphere that's never been detected anywhere else except deep space. The discovery was made using the Atacama Large Millimeter Array, ALMA, that's made up of 66 radio antennas. These all work together, creating a single giant telescope. ALMA uses a technique known as interferometry, where all antennas are pointed in the same point in the sky. The antennas pick up a signal from the target in the universe and join forces to analyze the signal. By combining radio waves from the antennas using a supercomputer, researchers can obtain extremely high precision images. In order for ALMA to get these images, there must be a perfect synchronization between all 66 antennas and the electronics with the precision of a millionth of a second. Using this incredible technology, researchers found something they didn't expect to find: a weird molecule called cyclopropenaldine. C3H2 is a strange organic molecule that doesn't exist terrestrially on Earth and can only be seen in a laboratory. C3H2 was first discovered in clouds of gas and dust throughout the Milky Way, including the Taurus molecular cloud. This simple carbon-based molecule may be a precursor to more complex compounds, and it could form or even feed possible life on Titan, like organic molecules that formed life on Earth between 3.5 and 3.9 billion years ago. C3H2 is the only other cyclic or closed-loop molecule besides benzene to have been found in Titan's atmosphere so far. Closed-loop molecules like it are important because they form the backbone rings for the nuclear bases of DNA and RNA, which is also a critical compound for life's functions. However, C3H2 is not known to be used in any modern-day biological reactions. NASA says the molecule could be an indicator for life, since something has to be generating an unstable molecule. If there is life on Titan, it would be incredibly different from water-based life forms we know of. Interestingly, daytime isn't the brightest part of the moon's day. According to computer simulations, the brightest it gets on this mysterious world is during twilight, up to a factor of 200 compared to daytime. This is something that happens because of the way light is scattered by the haze particles in the atmosphere. And since Titan is tidally locked, with a permanent daylit side and night side, there is also a permanent twilight zone, a border in between the two sides called terminator. Titan, like Earth, experiences eclipses, which can last up to 6 hours. This is like having a second night in the middle of the day. Of course, you'd only notice it if you were on the side of Titan facing Saturn. Otherwise, a solar eclipse would happen during nighttime. Understanding this is important, as it tells scientists how much light Titan's atmosphere and its surface receives from the Sun, which dictates what conditions potential life on Titan would have to live on. Just recently, the James Webb Space Telescope was able to detect clouds that form in Titan's lower atmosphere during late summertime, when its surface absorbs more heat. And this means that the Moon has seasonal weather patterns, just like scientists have predicted it. Titan's tilt relative to the Sun closely resembles that of Saturn, so both celestial bodies experience seasons of approximately equal duration, changing about every 7 Earth years. Although at a slow rate, seasonal shifts bring change in weather on Titan. When the Earth's axis is tilted neither away nor toward the Sun, something interesting happens. Imagine a line that cuts through the north and south poles, dividing the planet in half. During this time, occurring twice a year, night and day have about the same length all over the world. This phenomenon is called the equinox, and Titan experiences it too, although less frequently, about every 15 years. But when this time of the Moon's year comes, enormous clouds of methane form in its equatorial regions, bringing about severe windstorms. During summer on Titan, the wind blows stronger. During the Cassini mission, scientists saw waves on Titan's lakes, and they were unlike any waves here on Earth. Titan's weak gravity allows these waves to be much bigger, about 7 times taller than waves in the Earth's oceans. But they move more slowly, up to 3 times slower. Winds on Titan also fuel powerful dust storms. Something like this happens in arid areas on Earth too, when big dust clouds form right before storms. The only other place in the solar system this phenomenon has been detected is Mars. This is how organics in the form of dust are scattered around Titan's surface. And although downpours are a rare phenomenon on Saturn's largest moon, when they do happen, they leave behind a fascinating footprint. Titan's rains are heavy and have a big impact on the surface. They create something called alluvial fans. These features are a bit like piles of dirt and rocks shaped like triangles. They form when water or ice flows and leaves behind the stuff it was carrying. Scientists have also detected dune fields on Titan, taking up to 13% of the moon's surface. Compared to sand dunes found on Earth, they are enormous in size, hundreds of miles long, 1.2 miles wide, and 330 feet high. There's more sand on Titan than anywhere else we know of, although this sand isn't made of silicates like it is on our planet. Instead, it consists of solid hydrocarbons that fall like rain from the atmosphere. On Earth, we understand how landforms are created through a straightforward process. Rocks break down into tiny grains. Wind carries these grains to specific areas. They pile up, and eventually they shape the land. But on Saturn's largest moon, things are more puzzling. The origin of its landforms has been a mystery because the sand grains on Titan are quite different from those on Earth. They're weaker and thought to be more temporary. However, despite this, we've observed long-lasting sand dunes on Titan. When the wind transports sand grains, they should collide with each other and the surface, which usually makes them smaller over time. So how do these grains manage to stick around long enough to form significant landforms? After studying Titan's landscape, scientists discovered something fascinating. It turns out that the moon has a special type of sedimentary process known as sintering, where neighboring grains smash together and fuse into larger, stronger pieces that are less likely to be blown away by the wind. If sand on Titan can adapt in such a way to form complex landforms, could life have adapted similarly? There are a lot of similarities between our home planet and this alien faraway world. The problem with Titan is its ingredients seem to be all wrong. What's water on Earth is liquid methane and ethane there, including its clouds, rivers, lakes, and seas. But one thing is certain, this celestial body is still active. Even liquids flowing on the surface of Titan involve complex physical processes. Similar to water bodies on our planet, methane lakes on Titan can stratify, that is, create layers depending on density difference. And not only that, but the liquefied methane and ethane lakes could potentially erupt. This happens due to the combination of methane, ethane, and nitrogen, resulting in bubbles powerful enough to shape river deltas within the moon's liquid bodies. Understanding how bubbles form in Titan's lakes helps scientists explore how liquids behave on this intriguing moon. Imagine if a submarine was sent to explore Titan's lakes one day. If it gives off heat, it could actually cause an explosion of bubbles, just like the ones scientists have discovered. So these findings not only tell us about Titan, but also hint at some surprising challenges a future spacecraft might encounter in those alien waters. Whatever life forms could potentially exist there, they would have a completely different biology, and so they would look and act like nothing we've ever seen before. According to a team of researchers from Cornell University, it's possible for cell membranes to form in the conditions present on Titan right now. On Earth, cell membranes are made up of special molecules called phospholipids. Imagine these molecules as having a head and tail. The head is a bit like a magnet, with a positive and negative side. The tail is neutral, meaning it has no magnetic quality. Imagine these molecules in water, like a sandwich with 2 slices of bread. The heads of the molecules are like the outer sides of the bread, and they really like the water, so they face outward. But the tails of the molecules are like the inside of the bread, and they want to stay away from the water, so they hide in the middle. This arrangement makes the membrane flexible, something that's crucial for life. If there's any form of life on Titan, it would probably need to have a similar membrane. The problem is, methane has an even distribution of electrical charges, so Titan doesn't have the right conditions to make these Earth-like membranes. Because of this, life on Titan would have to find a different way to build its cell walls. But scientists have been able to create inside-out membranes in such non-polar liquids in a laboratory, and they believe that titanium cell membranes would have a similar structure, although they would have to be composed of something else, as liquids on Saturn's largest moon probably lack phosphorus and oxygen and are too frigid for phospholipids. So what kind of a molecule could this be? Although the titanium atmosphere is mostly made of methane and nitrogen, it has traces of different compounds as well. Computer models have shown that a substance called acrylonitrile would be able to form cell membranes in a non-polar liquid methane on Titan. The Cassini mission has previously detected small amounts of acrylonitrile in the Moon's atmosphere, about 10 parts per million. Even though there's a vast difference in temperature in which Earth-like membranes form and titanium membranes could form, they both share surprisingly similar qualities, like stability and internal resistance to external force. So it's possible for membranes to form in frigid temperatures of Titan's lakes and survive there. The possibility of methane-based life would change our entire outlook. Instead of focusing solely on planets in the habitable zone of stars where conditions are Earth-like, we'd also explore worlds farther from their stars where methane can exist as a liquid. Within our galaxy alone, the number of potential places to find alien life forms would skyrocket. And if life on some of these worlds has persisted for long enough to develop into complex organisms, we might find a living counterpart of an imaginary creature like those mentioned in fantasy movies and books. But even if at this late stage of Titan's history life cannot survive on its surface, there's a subsurface ocean of liquid water hiding beneath the Moon's icy coating. Scientists are trying to find out if organics can penetrate through this ice shell into the ocean. If this is something that happens on Titan, then this subsurface water could be potentially habitable. Although we still don't know much, like what the density or composition of this global ocean is, its temperature, and how it interacts with the icy crust above. Another big question is whether there's a source of chemical energy down there to allow for metabolism. But one bacterium with a rare metabolism that's been found on Earth could potentially live in the Titan's subsurface ocean. Billions of years ago, the Earth had a very different atmosphere, with high amounts of nitrogen, CO2, and water vapor, which descended to the surface, launching a life cycle. The building blocks of life on our planet may have once been the same ingredients we see today on Titan. In a way, Saturn's largest satellite is a real-life lab where astrobiologists can study how these ingredients might have played a role in the beginnings of life on Earth. Perhaps some millions or billions of years into the future, the Moon will evolve into a habitable world, teeming with Earth-like organisms. Soon, we may find out the answer to these questions. Planned to be launched in June 2027, NASA's Dragonfly robotic helicopter will search for water or hydrocarbon biosignatures potentially present on Saturn's gigantic satellite. With Dragonfly's arrival, scientists hope to uncover clues about Titan's subsurface ocean, its potential habitability, and whether the ingredients for life might indeed be present in this distant world. Europa is one of the 95 moons of the gas giant Jupiter, a mysterious, cold world with a diameter of 1,940 miles, which is about 90% the size of our moon, entirely covered in ice, exposed to incredibly intense cosmic radiation, and with extremely low surface temperatures that drop below -150 degrees Celsius. At first glance, it may seem like a barren, dead world, but currently this icy moon is considered one of the most promising places in search of extraterrestrial life. Here's why. In 1997, while following an extremely low trajectory just 125 miles above Europa's surface, the Galileo spacecraft managed to capture an extremely strange phenomenon. In one section of the moon's surface, there was something resembling a water vapor eruption. At the same time, scientists observed an anomaly in the readings from Galileo's magnetometer. Analysis of this anomaly showed that this kind of phenomenon can occur when water vapor molecules are ionized by sunlight. This means that the Galileo spacecraft didn't just fly near a water vapor eruption from beneath Europa's ice, but flew directly through it. Later, the Hubble Space Telescope, when studying the icy moon, provided new evidence of geysers on its surface. In 2013, it managed to take several photographs of the moon, where it's possible to spot traces that were presumably left by giant geysers in the section on the lower left. Scientists believe that these geyser jets reach several hundred kilometers before crashing back down to the moon's surface. According to calculations, every 8 minutes, there's enough water ejected from beneath the ice to fill an Olympic swimming pool. Indeed, there's plenty of liquid water out there. The depth of Europa's subglacial ocean may reach 60 miles, and the total volume is likely to exceed double the volume of Earth's oceans. But geysers are not the only clue the scientists have. It was recently established that Europa's crust rotation speed varies. Sometimes it moves faster, sometimes slower. This means that the crust movement differs from the speed of rotation of the Moon's internal part. The cause is attributed to the gravitational influence of Jupiter. The tidal forces of the gas giant cause deformation, which makes the icy crust slowly and unevenly slide over the subglacial ocean. This is direct evidence that between the icy shell and the solid core of the Moon, there's a vast ocean of liquid water, which makes this chaotic movement of the icy shell possible. Additionally, Jupiter's gravitational force may also be a source of energy for the subglacial ocean, keeping it in a liquid state. The side of the Moon closer to Jupiter experiences stronger gravitational pull from the gas giant than the opposing side. This creates a stretching effect, causing fractures to appear on the surface of Europa. Fractures that were first seen by the photos shot by Galileo. Moreover, it's likely that the Moon is heated from within due to tidal processes and friction caused by its flexing. Galileo also detected a strange disruption in Jupiter's magnetic field structure in the space surrounding Europa. This anomaly suggests that the magnetic field is distorted due to its interaction with an electrically conductive liquid beneath the Moon's surface. Based on Europa's icy composition, scientists believe that the most likely material responsible for this magnetic signature is a global ocean of salt water, hidden beneath a massive ice sheet, estimated to be about 10 to 15 miles thick. Any radiation or other external influence cannot reach this water world, which means that there is no threat to potential life and its evolution. But why do scientists believe that in such extreme conditions, far from the sun, under a thick ice layer, it is nonetheless possible for extraterrestrial life to exist? And how complex might it be? We already know that liquid water is essential for life to emerge, and Europa has more than enough. Furthermore, the water on Europa is in constant motion, interacting with the silicate mantle, which means that mineral compounds are being washed away, providing resources for potential life forms. Thermal energy, which is another key component for life to exist, is present inside Europa due to gravitational deformation processes. Sunlight is not always required. Additionally, there are hypotheses that volcanic activity could be another source of energy. If there are volcanoes harbored beneath the ice, they could create the necessary conditions for life. Examples of this exist on Earth, where volcanic rocks on the ocean floor interact with salt water, creating chemical reactions that generate energy and enable microbes, worms, and other organisms to thrive. Similar deep-sea vents might exist on Europa. Additionally, the most important condition for the emergence of life is the presence of chemical elements, the fundamental building blocks for all living things. Recent studies suggest that these elements are indeed present on Europa. Just recently, the Hubble Space Telescope managed to detect carbon dioxide out there. The data analysis indicates that the carbon dioxide likely originated in Europa's subsurface ocean, rather than arriving on a meteorite or other external sources. In an infrared image taken by Hubble, a white spot of carbon is visible against the blue surface of Europa. Notably, this carbon dioxide was deposited in a geologically recent timeframe. And this intriguing discovery suggests that, as we speak, something may be alive beneath Europa's ice. In addition to carbon dioxide, traces of hydrogen peroxide have been found, which is essential for a process known as methanogenesis, the production of methane by anaerobic archaea. Another astonishing discovery was made by the Juno spacecraft. On September 29, 2022, while flying over Europa just 220 miles above its surface, it detected atomic hydrogen ions emanating from the Moon's atmosphere, indicating a significant amount of oxygen produced as a result of radiation particles bombarding the satellite's surface, subsequently breaking water molecules into hydrogen and oxygen. Researchers estimated that Europa produces around 12 kilograms of oxygen per second, enough oxygen to supply 1 million people to breathe for an entire day. Scientists have speculated that some of this oxygen could be reaching the subsurface ocean through geological processes. If this is the case, the presence of oxygen in Europa's ocean further increases the chances of life there. Finally, for life to begin and evolve, it's crucial to have a stable environment, and most importantly, a vast amount of time, something Europa has had an abundance of. According to the latest estimates, this ocean could have existed as long as our solar system, more than 4 billion years. Throughout this time, the subsurface ocean has been isolated underneath enormous ice sheets, providing a stable, safe environment for any potential life forms to emerge. Given such an immense time span, even in less favorable conditions than those on early Earth, the probability of life emerging remains pretty significant. And if life does exist on Europa, what might the scientists expect it to look like? It's believed that any forms of life discovered over there would likely be primitive, similar to bacterial life that emerged from Earth's deep-sea vents. While some scientists involved in the project dedicated to studying Europa claim primitive life forms as their most optimistic expectations, others, on the contrary, take it a step further, hoping to discover complex multicellular life. According to their hypothesis, something akin to chemotrophic bacteria might inhabit Europa's subsurface ocean, forming layers of organic deposits on the ocean floor. Other life forms would feed on these deposits, analogous to herbivores on Earth. Respectively, they would likely be predators, possibly resembling sharks. These creatures would have to thrive in complete darkness and under the immense pressure created by the thick ice and ocean depth. While such speculation may sound fantastical, it's not entirely unfounded. Another compelling argument in favor of the feasibility of the hypothesis that there might be life under the crust of the icy moon is one of the most significant geographical discoveries of the late 20th century. In 1973, a research expedition in eastern Antarctica discovered one of the largest freshwater subglacial lakes in the world, named Lake Vostok, which we discussed in another video. It's buried beneath 2.5 miles of ice and has been in total isolation from the outside world for millions of years. Water samples from this lake revealed the presence of unique bacteria. Conditions in Lake Vostok are believed to be not too dissimilar to those in Europa's subsurface ocean. This unique finding on Earth gives us reason to believe that life could indeed exist in such seemingly dire and extreme conditions. In order to determine whether Europa's ocean could conceive and support life, NASA launched the most ambitious planetary exploration mission in human history, the Europa Multiple Flyby mission. The star of this mission is the Europa Clipper spacecraft. Despite the complexity and risks of the mission, there are high hopes for Europa Clipper, and it's the most technologically advanced spacecraft ever sent to Jupiter. The launch took place on October the 14th of this year. The spacecraft was launched into space by the SpaceX Falcon Heavy rocket, which allowed Europa Clipper to follow a trajectory that will eventually take it to Jupiter. This is the largest space vessel NASA has ever sent to explore a planetary body, weighing 12,500 pounds at launch. With its antennas and solar panels fully deployed, it spans 100 feet from one end to the other and is about 58 feet wide. That's larger than a basketball court. The solar panels were given a special role to play. They were built at Kennedy Space Center in Florida and measure about 46 feet long and around 13 feet high. These panels are the largest ever developed by NASA for a planetary mission. This is no coincidence. The size is necessary to capture as much sunlight as possible while exploring a moon that's 5 times farther from the Sun than Earth. Europa Multiple Flyby mission has become NASA's most expensive planetary mission in history, costing $5.2 billion, which is about half the cost of the Hubble Space Telescope and twice as expensive as NASA's most recent Mars rover. Europa Clipper carries 9 advanced scientific instruments on board, which will begin working in sync as soon as it reaches Europa. Among them is a radar designed to penetrate the ice. It will send radio signals into Europa's icy shell and analyze the reflected signals to reveal the moon's internal features. High-powered cameras will map Europa with far greater resolution than previous missions. The best of these cameras will be able to detect features on the moon's surface as small as 20 inches in certain areas. These images will be 12 times clearer than the most detailed images taken by Galileo. Meanwhile, an infrared thermal imaging system will attempt to search for warmer areas on Europa where liquid water may be close to the surface or may have been expelled. As the radar and cameras will be observing from a distance, other instruments will directly sample the surrounding environment, collecting gas and dust from space to determine their chemical composition. In addition to the scientific instruments, Europa Clipper, like many past robotic explorers, carries messages from Earth. This time, it includes a poem by US Poet Laureate Ada Limon, signed by millions of people from nearly every country in the world. Their names were inscribed on a microchip attached to a tantalum plate that seals the spacecraft's electronic storage. The plate also features wave-like patterns of water with the word water spoken in over 100 languages. Quite an inspiring touch, given the spacecraft's destination. Europa Clipper will need to travel a long distance. The spacecraft will cover nearly 1.8 billion miles before it reaches Europa. Traveling such an enormous distance using only its engines for acceleration would be impossible, as it would require an unimaginable amount of fuel. As such, Europa Clipper will use the gravitational forces of Earth and Mars to accelerate. Next year, it will pass by Mars, then follow a trajectory resembling an elongated loop, returning to Earth in 2026 before heading toward Jupiter at an even greater speed. It's expected to reach its destination in 2030. As it approaches the target, Europa Clipper will fire its engines for 6 to 8 hours to slow down and enter the orbit around the planet. This will set the spacecraft up to orbit Jupiter 49 times, getting as close as 15.5 miles to Europa. However, even way before slowing down to orbit around the gas giant, Europa Clipper may face serious challenges. Jupiter emits the highest levels of radiation in our solar system, excluding the Sun. As Europa orbits this gas giant, it passes through these hazardous radiation belts, posing risks to spacecraft. To protect Europa Clipper, its electronics are housed in a storage compartment made of dense aluminium and zinc walls, which should offer adequate protection, though some risks remain. The mission around Jupiter will last 4 years, during which Europa Clipper will make 49 close flybys of the icy moon, collecting all kinds of data. The main objectives of this mission will be to determine the exact thickness of Europa's ice shell and the ways it interacts with the ocean beneath, investigate its composition, and characterize its geology. Additionally, using its powerful cameras, the spacecraft will identify the best site for a future landing module, one that would be the most promising for further research, such as areas where the ice is thinner compared to other regions. At first glance, it might seem that Europa Clipper has little chance of finding extraterrestrial life while studying the moon from afar. However, that's not entirely true. The spacecraft will also search for the very thing that triggered active research of this icy moon: giant geysers. Scientists hope Europa Clipper will have a similar experience to Galileo, which passed through the plumes of water vapor emitted by a geyser. If life, whether bacterial or multicellular, exists in Europa's sub-ice ocean, traces of this life could be found even miles above the surface of the satellite. Presumably during geyser eruptions, water and ice particles shoot up to dozens of miles above the Moon's surface. Bacteria could easily be frozen in ice particles and delivered straight to Europa Clipper via the plume as the spacecraft passes by. Of course, the chances of an event like this are extremely slim, but should not be ruled out. Everything ejected from the depths of Europa could carry evidence of potential life if it exists. After completing its mission, in 2034, Europa Clipper will make a planned crash landing on Ganymede, the largest moon around Jupiter, and, as it happens, the largest in the solar system. Interestingly, Ganymede is also believed to have a subsurface ocean. However, its ice shell is very thick and may extend to depths of 100 miles, making it more difficult to study the environment beneath. Another of Jupiter's moons, Callisto, may have an even thicker layer of ice, potentially hiding an ocean beneath. Geyser eruptions have also been observed on Saturn's moon Enceladus, but it's much farther from Earth. The same is true for Saturn's moon Titan, which is also believed to harbour a subsurface sea. As far as Europa, we'll learn whether its oceanic world under the ice is suitable for life in just a few years. Perhaps for the first time in history, we'll discover life beyond our home planet. And no matter what predictors or speculations are floating around, we won't know for sure until we try.